turns out that arrays and pointers have a very close relationship, illustrated by this picture here. If we declare an array A that has 8 elements, the compiler will allocate 8 words in memory, or however many words it needs for those 8 integers, and the symbol A refers to the beginning of that memory space. So the symbol A is actually a pointer. It stands for the address of the beginning of this array. Now it's not a pointer variable because we can't change it. We can't assign anything to A. A is fixed once this has been allocated. But we can create a separate pointer P. So we declare a pointer variable P here, which gives it its own memory location, and then we initialize it to be the same as the symbol A, which means it's the address of the beginning of this array. So P now points to the same location that A points to, and that pointer and the array name can be used interchangeably. And when we index into an array, we're actually doing pointer arithmetic. So the first element of array A we refer to as A sub 0, A0, right? And that's the same thing as if we dereference this pointer P, it's pointing here, we get that same value. So A0 and star P refer to the same value. A1 is element 1 of the array. So if you're thinking about how the compiler would get that value, it would go to the beginning of the array, move up 1 spot, and read this value. Well, that's the same as if we dereference, if we add 1 to our pointer and then dereference it. So if we add 1 to P, we get this address here, and we dereference it, we get that value. So A1 and star P plus 1 are also equivalent. And that's true for any value of I. AI and star parentheses P plus I are exactly the same value. They refer to the same place in memory. They load the same value every time. So these two ways of expressing that value are equivalent. So if we were to write a loop that adds up all the values in the array, here I've shown 4 ways to express that loop, and they all do the same thing. So this is what you might think of first, right? We take an index, and we go from 0 to 7, so I less than 8, so 0 to 7, and we add each value into the sum. So A0, A1, A2, blah, 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 A7, right? So that's the most straightforward way to do it, and I recommend that way. Here's an equivalent way to say it. We just replaced A sub I with star P plus I. Okay? So this is equivalent to that. This is a lot harder to read, in my opinion, than that. This makes a lot of sense. We've got an array, we're stepping through the elements of it. This, you have to remember what the pointer is and so on. So, there's no particularly good reason to write the loop this way, but it is equivalent to that loop. Now let's look at this loop instead. Here, we're not adding I to P each time through the loop. We're actually changing the value that's stored in P. Remember, P is a variable, so we can assign to it. We can do operations with it and change it. So here we're going to add in the value that P points to, and then we're going to move P by adding 1 to it. Then we go back and we do this again, and we do this 8 times. And by the time we've done this 8 times, we've visited each element of the array. This is a very common way to do this loop. But one thing that's different about this loop than these loops is that now P has changed. So at the end of this loop, P no longer points to the beginning of A, it points past the end of A. So if you wanted to reuse P again, you'd have to reset it and so on. Now this is so common, this is a much more abbreviated way, well, somewhat abbreviated way to write the same loop. This is a common construct that you'll see. So let's talk about it. Sum plus equals star P plus plus. Okay, so what does that mean? Well, the plus plus has a higher precedence than the star. They're both unary operators, so they go from right to left. So we do P plus plus first. We increment P. But it's a post increment, so we use the old value of P. So we dereference the old value of P and increment P at the same time. So this is essentially doing these two steps in one single expression. Again, this is exactly the same as this. It performs the same function in terms of calculating the sum as these two, but it does change P. Now let's talk about how functions are used, how arrays are used in connection with functions. When we want to pass an array to a function, an array is the only thing in C that gets passed by reference. So array is always passed as a pointer. So we declare a function, array sum, and its parameter, its first parameter, is an array. Now, look at this. I've said earlier you can't have an indeterminately sized array. Well, you can't declare one, but this is something that's being given to us. It's already been allocated, and all we need to know is where it begins. So we don't know how big it is, and all we're saying is that we're given an array, and we're going to call it X. We're going to call the beginning of that array X. And it's actually a pointer. So we could just as well have said X is a pointer to an int. These two ways of expressing this are equivalent. The other thing that we pass in to a function is the size of the array. There's no way to look at the pointer that we're given and look at that array and understand how big it is, because all it is a pointer. It just says here's where something begins. There's no information there that says this has 8 elements or this has 25 elements or whatever. So almost always when we pass an array to a function, we need to pass the size of that array to the function, unless there's something implicit that we always know when we get an array it's got 8 elements or something like that. So I've got the pointer and the size that I'm passing in. Here I've declared a sum, I've got I. Here are two ways, right, to write the loop to sum up that array. We use an index I goes from 0 to n minus 1, and we add up all the elements, here x of I, or we can use x as a pointer. We can increment the pointer and dereference it each time through the loop. We still do the loop the same number of times. These two are the same. Here we're changing what's stored at x, here we're not, but we're using array notation or pointer notation, and either one is okay. And it doesn't matter which of these we said up here. Even if I said int star x, I could still do x of I. Array notation, pointer notation are completely interchangeable. So what does that function look like from the outside when we pass something to a function? So here we've got an array A that we've allocated. It's 8 elements of integers. When we want to pass that into array sum, we just put the name of the array. The name of the array, as I said on the very first board here, is a pointer, right? This symbol represents the address of the beginning of the array. So it is a pointer. So when we pass an array, we generally just put the name of the array here. So we're saying here's where the array begins, here's its size, please sum them up and return the value, and we'll store it there.